Good morning, everybody, and welcome back to Next Door Net Admin. Ethernet. It's what everybody uses for networking. Most commonly. I know it's not literally everybody. But there are some details to how Ethernet works. And this came to mind when I had a comment this last week from at the Anna guy saying, you know what, auto negotiation, that's a thing, but how does it work? And then he said, well, I don't know if that's sufficient to do a deep dive on, but it is. Because we're going to talk about auto negotiation, but also MDI and MDI-X, because that kind of fits into the same bucket. And there's a surprising amount of complexity there that is good to know about. Not necessarily for everyday use nowadays, but both historically and because if you're working with older equipment, sometimes this kind of knowledge is really useful for troubleshooting. So let's get into it. Auto negotiation. This comes of the fact that older Ethernet specifications had various options for half or full duplex, and then the various speeds. Half or full duplex, incidentally, is whether both sides can talk at the same time, essentially. Half duplex, only one side can talk at a time. Full duplex, both sides talk at the same time. This is a legacy from Ethernet's original bus architecture for CSMA/CD, carrier sense multiple access with collision detection. So on a bus, everybody's got the same wire connected to their network card, and only one station can transmit at a time to put signals on the wire. Everybody else has to listen. And if you had two stations attempt to speak at the same time, then they would cause a collision, and you would have them both send out the jamming signal to indicate to everybody that there has been a collision. Do not take what you have received as accurate because it's been garbled in transit. And then after a short back off time, somebody tries to send again, and you just hope that you're not going to hit a collision. But that is half duplex by its very nature. And so when you got into twisted pair as your transmission medium, you still by default have half duplex, as a mode of operation, where only one side can talk at a time. Full duplex, you've got separate pairs for transmitting and receiving, so both sides should be able to talk at the same time, but it requires the circuitry on the network card to be able to handle both at the same time, which was not a given originally. These days, it would be shocking to find something being sold that doesn't support that. So, fine. But that's a mode of operation. Same as when you had twisted pair come out, that was very much a 10 megabit standard. And then over time we went to 100. And since then we've got gigabit. And then you had 10 gigabit. And then you got some additional standards there where not everybody needed 10 gigabit. So then you got MGig, multi-gigabit, which has 2.5 or 5 gigabit, kind of in between 1 and 10 gigabit. So you got different speeds. Ethernet has something that makes it quite lit. Something I referenced in the thumbnail for this. Lit, in this case, is a link integrity test. And this is how a system knows that its Ethernet media is connected and functional. It has to send a link integrity test anytime that media is connected. And if it does not receive a frame or 2 successive link integrity tests off the wire, then it knows that the link has failed. So there's always link integrity tests being sent out there. And in its most basic form, this just takes the form of a positive pulse on the wire. It's just, here it is, every so often. And the every so often is like, I want to say somewhere between 10 and 20 milliseconds. I saw the exact number earlier, but I just don't remember it right now. I think it's something like 12 or 18 plus or minus 6, or plus or minus 16. There it is, 16 milliseconds plus or minus 8. So there's a range where this is acceptable. But then you got to, okay, well, what if we have 100 megabit? How do we distinguish this? Because if you can distinguish the speed on the wire, then it would be useful to have some sort of auto negotiation so that both ends know that they can use the higher speed without an administrator having to configure it manually. So you get a variety of, or a variant, I should say, of the link integrity test. That link integrity test, the LIT, became renamed as a normal link pulse. It's just a pulse on the link, and it's just there to tell you that it's there and it's working. Okay. But now you have a variant, which is the fast link pulse. A fast link pulse is actually several of these at a much faster rate. Not more frequently, but when one of those windows comes around, it sends a few very fast pulses to show that, you know, there's a device here which can do it faster. It's done this way because if a slower device is there and it's just working at the speed of 10 megabit, it's going to see and interpret this as a link pulse, and it will send a normal link pulse back because it doesn't have the necessary revolution to see that there's actually several fast pulses in here. So if you have a fast link pulse, you know that the other end is capable of 100 megabit transmission. And then it extended it as well so that there's a data word that's transmitted on the line that tells the other systems what capabilities the transmitting device has. Okay, it's got a fast link pulse. That means it's capable of 100 megabit. But it will also say that it is in the data word that it's capable of 100 megabit full duplex, 100 megabit half duplex, 10 megabit full duplex, 10 megabit half duplex, and it'll add whatever modes it's capable of in the fast link pulse. So at higher speeds, like gigabit, it might also have gigabit full duplex plus all the lower modes, and if it doesn't support some of those lower modes, it won't include them so that it can't negotiate to it. And then once the devices on the wire can see what each end supports, then they can agree on using the fastest, the most capable option that both of them support. If you're looking at 100 megabit, then that's 100 megabit full. Cool. But what happens if this negotiation process doesn't work? It might not work because one of the devices doesn't support this negotiation. Or it might not work because something is garbling the transmission on the line, such that you're not getting the proper control word, you're not getting the list, the output of what capabilities are there. In that case, then it will default back to the most basic settings, which is 10 megabit half duplex. And because of this, it used to be a pretty common troubleshooting step. I don't know how common it is now, but it used to be a common troubleshooting step to switch it into a manual mode and set it manually 100 megabit full duplex. Okay. If that is the case, then on your other device, you have to do the same thing. Because if you set it to a manual setting, it's not going to do auto negotiation anymore. And if your setting is 100 megabit full duplex, and you leave auto negotiation on the other side, then it's going to see a fast link pulse, and it'll know that it's 100 megabit, so it'll go to 100 megabit. But if it can't auto negotiate the duplex setting, what you can end up with is that one side is 100 full and one side is 100 half duplex. And this is a really tricky situation to be in, because as long as both sides aren't trying to talk at the same time, the link will work and you won't have an issue. But if the half duplex side is sending and the full duplex side says, oh, well, I should be able to send and receive at the same time. I'm receiving, I'm going to send. If the side that's in half duplex sees that, it will sense it as a collision. And it will emit its jamming code and reset everything. So what you'll get is that if the line is not busy, it'll look fine. But as soon as you start trying to put a little more traffic on there, you'll get random drops or things that don't work, or the line just, seems to drop everything it's doing. And that can be difficult to troubleshoot. And that's because you've got both sides agreeing on 100 megabit, but the duplex is not correct. So if you have one side on auto negotiation, both sides should be on auto negotiation. If you have one side that's set to manual, you should set the other side to manual and make sure the settings match. Or else you're going to have weird, unexplained issues to troubleshoot, and that's tricky. Gigabit is slightly different in that both 10 megabit and 100 megabit have two pairs of wires in use. There's a transmit plus and minus, there's a receive plus and minus. And then the other two pairs in your standard twisted pair cable, which has 8 copper strands in it, your other two pairs are not used, or they're used for grounding. In gigabit and higher, you're using all 4 pairs. So this used to be a thing back in 2010 when my company's new office was being wired. They went through and they connected the expected 2 pairs per line, but then there were a bunch of cables where they didn't connect some of the other wires, or they connected them incorrectly. And I had to go through and I had to mark them all, and I say, okay, well, this one's done correctly. This one will work at 100 megabit or 10 megabit, but it will not work at gigabit. This one is wired funky and it won't connect to anything at all. And I had to argue with the wiring person who's like, well, you don't need these wires. You do. If you're doing gigabit, you need these wires and they need to be done correctly. So every time a standard updates, it can take a little bit of time for the installers to actually learn that and learn to work with that. But here we get into MDI and MDI-X, because gigabit does use all 4 pairs. And you split your gigabit of transmission into 250 megabit on each pair. MDI in this case stands for Media Dependent Interface. And then if you have MDI-X, that is a Media Dependent Interface in crossover mode. What is this? Well, if you think about it, your standard straight through cable, pin 1 connects to pin 1, pin 2 connects to pin 2, pin 3 connects to pin 3. Cool. 1 and 2 are either transmit or receive, and I don't remember which. Terrible, I know. That's your transmit. And then 3 and 6 are the other one. I'll say it's receive. I don't remember which one is which one. But you have 1 and 2, 3 and 6. And the reasons for why you have this is another legacy thing entirely. Back when you had category 3 cabling or something that you were expecting to be able to run over phone wires typically had 4 wires, and they were configured so that the middle 2 were a pair, and then you added 2 on the outside for your second phone line. And so what you had is you had a center pair and then 2 around it, and that was how the wire was done. When Ethernet came along and you went to 8 wires, for compatibility reasons, you still have that in the center of the wire. You have 2 wires, 4 and 5, and then you have 3 and 6 around it. And then you have 1 and 2 on that side, 7 and 8 on the other. This is all, very much a legacy building of protocols and standards on top of each other. So there's that. But fine. For a straight through cable, you've got 1 and 2 transmitting, 3 and 6 receiving, we'll say. If that's the case, 1 and 2 connect to 1 and 2 on the other side. And that's the transmitting side. So transmit connects to transmit and receive connects to receive. You're never going to hear anything. You're not going to receive it because your receive's not connected to transmit. So what you have is PCs and routers have MDI interfaces where they transmit on 1 and 2 and they receive on 3 and 6. Switches and hubs in the middle of the network span, where the PC is one end and the router is the other end, switches and hubs have MDI-X interfaces, media-dependent interfaces in crossover mode, where they're actually going to transmit on 3 and 6 and receive on 1 and 2. So that if you're using a straight through cable between, say, a PC or a printer or what have you, talking to a switch, the PC will send on 1 and 2, and the switch will receive on 1 and 2. The switch will send on 3 and 6, the PC will receive on 3 and 6. If you needed to connect a PC directly to a PC, these are both MDI interfaces. So you would have to get a specific crossover cable that connected in the cable, pins 1 and 2 on one end, connect to 3 and 6 on the other, 1 and 2 on this end, connect to 3 and 6 over here. And that was a thing that you actually had to worry about. If you're going to connect PC to PC or PC directly to router, then you need a crossover cable because these are both MDI type interfaces. But then you got to a new development, which was a port type that is auto-MDI MDI-X, where the port itself will pulse and flip its state and listen to what the other side is doing to figure out one of us needs to be in MDI mode, and one of us should be in whatever mode allows us to receive the signals. So we're going to figure out dynamically which pair is transmit and which pair is receive. And that's an interesting thing to think about, because with this auto mode, you could technically connect a PC to a switch. Normally this requires a straight through cable. You could connect it with a crossover cable. And if both of the ports are auto-MDI MDI-X, then they'll figure it out, and they'll just figure out whatever. One person needs to have a transmit and receive pair, and the other one needs to have a transmit and receive pair that can actually hear and talk to the other side. You figure it out, or the devices figure it out. In gigabit, because all 4 pairs are being used simultaneously, auto-MDI, MDI-X really became an essential part of the standard, particularly because if you're using full duplex, and most systems are, you have to use all four of these pairs at the same time, both ways, which means that they actually require quite a bit of error detection circuitry to split out. I'm putting electrical charges on this line, and so I'm influencing what I'm hearing on the same wire. So they need the circuitry to disentangle, okay, this is my component of the signal, take that away, and what do I have still on the line? That must be what I'm receiving, and error correction sorts it all out and de-garbles it, and it's amazing to me that it works, particularly at 1 gigabit a second, and then 10 gigabit a second. It's craziness, but it's there and it works. So auto-MDI, MDI-X is something that you can expect to have on anything that is gigabit and higher. I've said before it's part of the spec. I looked at it. I don't know if it's actually a required part of the spec, but functionally it is, in my mind. And most of the time, I've only ever seen gigabit full duplex. Maybe there's a gigabit half duplex, technically, somewhere, but functionally, again, I've never seen it. If it's gigabit or higher, a lot of this older standard of auto negotiation being required and crossover or auto-MDI, MDI-X, all of that complexity, if you're in a gigabit or higher network, most of it's gone away at this point. But if for whatever reason you're looking at an older device or a cheaper device, something like a Fire panel, probably doesn't have a gigabit connection. It doesn't need all that extra circuitry. It needs very basic connectivity. It's probably 100 megabit or less, even 10. So depending on what you're working with, you might find that you need to actually do some of this manual configuration instead of using auto negotiation. You might even find that you need a specific type of cable if you're not connecting an end device to a midpoint device, PC, printer, Fire panel, whatever, to a switch. Straight through cabling is fine. If you have to connect that directly to another PC or to a router, if you don't have auto-MDI, MDI-X, you might need a crossover cable. And that's just some of the interesting complexity that comes up when you're looking at these types of standards that have been built up over time and built on top of what came before, so that you're always trying to maintain some level of backward compatibility to make sure that things work. And it's really useful to know for when you're dealing with stuff from different eras, we'll say, of network design. So hopefully you have found that interesting and informative. I know it's always fun for me to look at that kind of complexity. If you have other thoughts on things that you would like to hear me talk about or things that you would like to see me demonstrate, feel free to let me know right down there in the comments section. Otherwise, thank you very much for watching. I am your next door net admin, and we will see you next time.